All right, I think we are live. Today I have Christian Posta with me, a longtime friend and field CTO for Solo. I've known him for a long time from the Red Hat days.
Yeah.
Welcome, Christian, to our humble podcast.
Yeah. Good morning. Thank you for having me. Looking forward to the conversation.
Awesome. All right, good. So let me set the stage. We've been building an SR agent using agentic AI, and we ran into a couple issues and trying to understand certain challenges as well, especially when it comes to how do we expose these agents, how do we integrate with other agents, authentication, authorization, and at the same time, I've seen you writing a lot about this these days, right? Through blog posts and other mediums, and we've had a couple of private chats and some LinkedIn exchanges as well, and so we were always going to end up having a chat. So it was a really a good time, and so that's how I think we got talking because of what we were building. So Christian, let's sort of jump right into it. And
Yeah.
all right, so I have a couple of questions. Let's start with kind of the origins of the MCP, right? Like you've written extensively about the modern context protocol, right? So for the folks who may or may not be familiar, with this, can you just give us a bit of a quick intro, like what problems do MCP solve in the context of LLMs and multi-agent systems?
Sure. Yeah. So models, I would say, are primarily used for reasoning, and especially the ones that LLMs that we see are used for text output. But these models have also been trained to understand, as part of their decisioning, can they call out to functions or tools. And so the way that works is, as a developer, when you make the API call to the model, you say, so here's the system prompt, here's the user prompt. Oh, and by the way, here's a list of tools and their descriptions, their schemas. This is what it looks like to call them. These are tools that you have available, and so use them if you need. And so you send that prompt, you send that API call to the provider, to the model, and then the model will do its reasoning based on the prompt, and then it might say, oh, and by the way, call this tool, the get weather tool. I think that's one people use all the time, for example. And so in the API, so you make a HTTP post, it sends the prompt and the tools. It'll respond with oh, can you make this call and give me the results? Right. So if you look at the API, it'll say tool call get weather and city, Phoenix, Arizona. You go call it and give me the answer. Right. And so now, as the agent or the application that makes calls to the LLM, I'll see, okay, the LLM wants me to make this call. So I'll go make it and get the response and send it back. And that piece right there is where MCP fits in. And the reason is because the LLM will respond in some sort of API specific way, whether it's OpenAI's API or Anthropic's API or Bedrock or whatever. And so now your agent needs to understand that API, decide, okay, now how am I going to call this? How am I going to call this weather? Is this on the desktop? Is this some sort of API? If it's an API, then I need to go understand what that API looks like, and then wire up the call to do it. Right. And so now translating from what the LLM is asking into what the actual call looks like, that had potential for being, you can do it anyway, and you still can, right? Um, but what MCP said, okay, let's standardize that piece. Let's standardize how the LLM calls out, or it initiates this call that the agent understands to then call out, and that call out to an MCP server, and the MCP server can implement the backend details however it wants, but connecting it up to the LLM through VS Code, through Claude Desktop, through ChatGPT, whatever, or any of your own custom agents, make that part a standard. And so that's where MCP came from.
Awesome. That's a great introduction. Thank you for that. All right, so let's kind of build upon that. And, all this time, and for a better part of, I guess the last, I'd say 10 years, we're dealing with API gateways, right? So now we're moving from API first to like sort of like a protocol first type of architecture. So how do you see MCP changing how systems or agents expose and consume capabilities? And people are always thinking API first. Now we are moving to this new paradigm. How do you see this sort of changing the way you expose
In
capabilities?
multiple ways. Let's start first with a lot of this exchange with agents and the AI models is happening over natural language, right? So language that you and I understand, the LLM understands, but in the API world, we dealt more with how the machines talk to each other, right? And so going from APIs that were defined by contracts that, with enough documentation, I guess, that a developer could understand when and where to use it, to more of now we need to let the AI models, we have to give enough context to the AI models to decide when to use a particular function. And so for that, we need to address the gap in semantics and capabilities that have always been, goals. How do we build semantically consumable APIs? But people, I feel like in practice would always stop short because it was extra stuff that once you got the contract in place and it's working, then let's keep moving. We got all this stuff to do and you got a deadline and blah blah blah. But in the world of AI models, we need to take that a little bit more carefully, right? We need to do that. We need to expose APIs with semantic understandings, more detailed descriptions, examples of when and how to use them, and keep all that stuff up to date. All right, so that's one aspect of it. How's just fundamentally different. Where it's not machines talking to machines anymore. It's humans at natural language. The second part is not just MCP, but definitely partly because of MCP and the nature of agents. Things go from where in one world in APIs, what we had was let's build these stateless APIs that could take a request on its own, do some processing, and then either call another API, call a database, do whatever. But the actual application itself didn't depend on what called before, right?
Right.
Now in the MCP world, that's not the case. In the agent world, that's not the agent itself. These agent applications are stateful applications. They are, and I can give you the simple examples are, agent is going to take a prompt from a user, right? Saying, hey, help me plan my day today. And so then the agent will combine that user prompt with a system prompt, which are the instructions for the agent that basically say, the system prompt might say, you're a helpful assistant, personal assistant, and more detail about how to behave and stuff. But so it'll combine those two pieces into a prompt that already you have a little state there. You have those two pieces and you send it to the model and the model is going to respond. Maybe we'll take the example we just did earlier. I give it hey, help me plan my day today. Here are some tools. The model responds with, hey, all right, go call the get weather tool. go call the get calendar tool, right? And these are responses from the model. We have to then go call these functions, these tools, get the data, return the data. But keep in mind, every time we loop and call back to the model, we have to send in everything before, the entire chat history before, right?
Yeah.
So we have to keep track of that chat history. And the more interactions, the more turns the agent has, the longer this state gets, and we have to we have to keep track of it. If it gets too long, we have to cut some of it. If it gets, maybe we summarize it, right? But so the agent ends up managing this state as part of the session, and so all the messages that are coming in from the user, coming responses from the tools, all the stuff, the ordering, all that stuff is significant. And so from an agent perspective, things are stateful. The MCP server has the same problem. The MCP server can support sessions, and by default, a lot of them do. Right? As soon as you connect up, it's an RPC style communication. You communicate with the MCP server. You send a JSON RPC message that says initialize. All right, you can't have any of the other messages unless you have an initialize. And the MCP server will respond saying, there'll be a handshake, just like with TCP. And now you have this session established. And the MCP server, once it makes tool calls and responses up, can keep the part, let's say it makes an API call to a database. It has this huge list returned. It needs to maintain the cursor positions and stuff and so on to return maybe paged lists in response. Or it might, the MCP server might make multiple calls to multiple backends. It's not just a single API pass-through. Multiple APIs that it calls. And it might keep state about, what is the current order, like if it's doing some analysis on customer orders. It'll go get the order and keep that, and then continue to call tools about that order, or backend APIs about that order. Right. So the MCP server now is stateful. Agent stateful, MCP server stateful. That's quite different than our world of stateless APIs.
Right. Yeah. Because for a while we were championing stateless APIs,
and to build scalable, highly available, fault tolerant style systems, those are good principles to have. Stateless is a good principle to have.
Right. So what that means is there will be challenges in building, scalable, highly available agentic systems.
Performant.
We're going to replicate the state, and we go back to those days of having to deal with all of that. Right. Yeah. Good. Great answer. I mean, very nice. Let's continue to build on that. So we talked about, exposing these capabilities and some of the challenges around, especially, with statefulness, etc. Right. Let's get into the other sort of challenges, right? Like, I think one of the hardest problems in MCP, or at least for now, it seems to be authorization, right? It's especially mapping the user identity to capabilities on MCP. So we've had a number of chats on this, right? Why is it such a challenge? And how do you see this being addressed? Do you want to shed some light on this?
Yeah, I think part of it, or there's multiple angles to this problem as well. But the part that enterprises care about is compliance, right? We don't want to be sending data to these AI models that we're not supposed to. We don't want to expose sensitive data to users that don't have access to that data. We don't want to get into position where the tool calls get hijacked and poisoned, And we're seeing a scenario now with the MCP server in place where we can get into a confused deputy situation that has always existed in microservices as well, but is much more interesting now because the sensitivity of the AI models and so on. So making that so that let's go back, continue our example where the AI model says, all right, I need this data. Now the agent could make the API call directly, or it could use MCP. And if it's using MCP, then it's calling to an MCP server. And now instead of the agent having all of the access and credentials and stuff directly, it needs to define what its access is to the MCP server. Now the MCP, so we're basically just kicking the can down the road, but the MCP server then has to figure out how to make any additional calls, API call. I think it'll be fairly common for MCP server just to be an aggregator of APIs. And so now as that MCP server is making upstream calls to APIs, what does it have access to? And it's making these calls on behalf of a user. So we need to take that into account. It's also making these calls as initiated and on behalf of an agent. So we need to take that into account, right? Because instead of like microservice A calling microservice B, you now have microservice A calling something else, some intermediary, and then calling B, right? And so we could write policies about A talking to B, but now we have this middleman.
Yeah.
And so that also screws up various things like, if the user were to log in and use their single sign-on or use their OAuth credentials and call an API, that we're sort of set up to do that. But if we introduce this middleman, then it kind of breaks the protocol, OAuth and other things. So there's some challenges there. And inside the enterprise especially, which has been my primary focus, things like the MCP spec are, if you look at the authorization part of the spec, they're written for OAuth 2.1. And inside the enterprise, they don't really use or want to use OAuth. And so there's this conflict between, well, what does the spec say? And then what are we supposed to do? So yeah, there's a number of angles and a number of challenges right now.
Good. So now let's sort of like dive a little bit deeper into it, if you don't mind. And so if people are building these capabilities now, and there's also pressure from the top, we gotta get our AI capabilities up and running. What can what can people do right now? What are some of the practical things that they can do to mitigate against some of these authorization challenges? And I understand the spec is evolving, and you already mentioned that OAuth is not that popular inside an enterprise. So what can people do in the interim to solve some of these challenges?
Yeah, I don't think we need to wait for the spec on this, especially in the enterprise. We have established ways of thinking, patterns, or especially around APIs. Some that actually should evolve. So yeah, let's go into more detail. So, right, OAuth was designed for the scenario where the user owns their data and wants to delegate some scoped down access to their data to some limitedly trusted application, some other party, third party.
Yeah.
Right. And so that's where OAuth is built, why it's built, and their focus is on the user granting these authorizations as defined in the actual OAuth protocol as scopes. So these scopes: can I read your email address? Can I see your whatever information? Can I access your calendar, etc.? And then you get these tokens, these bearer tokens, and then whatever client has those bearer tokens then can use it. Now inside the enterprise, and these are usually these scopes are fairly coarse grained. Access to my calendar. Yes.
Yeah.
All right. Well, that's a lot. Right. That's not access to add an entry to my calendar on Monday for this specific reason using this specific Zoom, right? It's not detailed. It's access to my calendar. All right, good. Now, within the enterprise, first of all, that scenario doesn't exist usually, where the user owns the data, right? Inside the enterprise owns the data. And so this idea of the user saying, yeah, application, you have access to my data doesn't really exist. All right. So what the enterprise cares about is they own the data. They own the systems inside the enterprise. They own the directory of users and employees, right? They know who those are. So OAuth doesn't really fit in that picture. What the enterprise cares about is who in their directory can use what systems to see what data, right? And so that's more about defining policies and auditing and making sure that these policies are being applied and withheld or upheld.
Yeah. And who accessed what kind of thing. Yeah.
And who did what exactly? Can we audit? Can we see who did what? And so in that world, we don't need OAuth. We don't need to wait for the MCP spec, in my opinion. We have pattern now. Some of the patterns and practices in place should be improved. So, for example, for identifying the user, we have a good mechanism for that. That's single sign-on. And so we can identify who the user is now, and we can build policies about what the user is allowed to access, and usually that's done in roles and role-based access.
Yep.
And so each system kind of defines what their roles are, and then we'll map users to roles, and then the roles have these permissions.
Correct.
Now in an agent world, we have to think that users, we can kind of give the benefit of the doubt of acting right for to some degree, right? That's absolutely not the posture we want to take, but with agents, we have to treat them as not trusted. The LLM and the model can decide to do things that are not in line with what we expect. And
always the possibility.
Exactly. And if we're just handing out these coarse-grained role-based access, then we should just assume that every bit of that role the agent will explore and try. And so what we want to do in the enterprise is not give these coarse-grained access, these roles. What we want is more of what we've been talking about for a while is this zero trust posture. For every request that comes in, we want to authenticate that request, know who's calling. And now in the agent world, we want to know that the agent might be doing this on behalf of the user. So which user is this? What action are they trying to take? And then we want to write policy about the very fine-grained actions that they're trying to take. And ideally, we want this done in a manner that we can manage, right? We want this centralized. We want some level of centralized access management.
Mm-hmm.
And enterprises have thoughts about what this might look like. Now, I would argue that most places are not as advanced to be able to support this yet today. And so we need to continue improving that. But the idea of policy-based access is very interesting inside of an enterprise. And I think there is a path, at Solo we're working on this, other people are working on this to help folks get there. Whatever is in the spec, we don't need to wait around. We can start moving right now.
Awesome. That's a very detailed explanation of this. That's awesome. Let me ask sort of a follow-up question, and this is something that we've chatted in the past as well, related to this. When people build these agentic capabilities, there's a bit of a choice or a trade-off to be made. If you make more coarse-grained capabilities, then we run into these. You talked about broader policies and other things that can have a negative impact from a security perspective. And if you create a lot of fine-grained capabilities, now you can enforce them a little bit more fine-grained. But what that also means is the amount of tools and capabilities that the LLM agents will have to look at and understand is also growing. And I think we talked about this a little bit about how that is becoming a challenge, because the LLM may struggle to find, and it's something that we've noticed too, to pick the right tool, because now there's just quite a bit of things to look at as well. So at some point we'll have to figure out some sort of a balance in trade-off performance and capabilities versus this from authorization aspect of it, right? What are your thoughts on that? I think we've chatted about this a bit.
Yeah, that's a good question. So to kind of restate what you were getting at there, if you give too many, so in the call to the LLM or the AI model, where we're saying here's the prompt and here's the tools, giving to get accurate results, you may have a lot of fine-grained tools, and you need to tell the LLM about those tools. This is the tool, this is the description, this is the schema, and that, first of all, could end up costing a lot of tokens, right?
Exactly.
You explode the amount of tool related context. So that's one part of it. The second is the LLM now has, let's say, I'll use a large number for like 100 tools that you're giving it, and it when it's making its decision about what tool to call, it can get overwhelmed. It
Yes,
can just
exactly.
start saying, all right, well, call this one. This one looks good, right? And then you start making these calls, sending more data back and forth. Oh, that's the wrong information. No, I need this one instead, blah, blah, blah. And you get into this loop and you spend a lot of tokens, and things just you don't get the output that you want as efficiently as you want. Right. So what we've learned in practice is, all right, so don't give the LLM too many options, too many tools. And so what that means is, if we're going to cut that down, then we need to think about, well, what is it that the LLM needs, and how would we implement that? Maybe we don't give direct, like if we look at our API catalog and we have 1,000 APIs, maybe we're not giving the LLM exactly the each detailed API. Maybe we're building wrappers around capabilities that the LLM needs that calls out to multiple APIs, right? And so now what we're saying, we'll give the LLM fewer tools, but those tools might do more things, right?
Exactly. And now we run into that challenge of how do you enforce? Yeah.
Right. But so it still comes down to the enforcement. I think there's a little, we can separate out, what is the policy, what's the enforcement, all this stuff from how we actually present those tools to the LLM, right? Because we have the same problem with microservices, where you have a microservice that aggregates 10 different backend APIs, but we still take into account, all right, well, A is calling service 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but on each one of those calls we want to make sure that that is a legitimate call, but the LLM doesn't have to see any of that. But in our policies now, we do want to know this is being called because of an LLM, and an agent called, initiated this, and then an agent initiated this on behalf of the user, and that might have been initiated by other agents, right? So in our policies, in microservice A or MCP server A calling API 1, 2, 3, 4, whatever, all the way to 10, when we make those calls, we can say, oh, you're trying to call service 3 and 4, and these didn't take the approach that we expected. It's coming from service A, but user foo initiated this, and we're not going to serve that on APIs 3 and 4. So you can still make fine-grained authorization decisions in the network on these applications, regardless of what the LLM sees. LLM might see a more coarse-grained API, but in the back end, how we actually facilitate that or implement that, we still want fine-grained authorizations on that.
Right, especially vetting the response that's going back, right, and figuring it out. Yeah, good. All right. Let me move on to the sort of like the next part of this. We did talk about this before as well. I know we talked about OAuth not being a great fit in the enterprise itself, but I believe you've written a little bit about how can we use scopes, and then map those into capabilities that an MCP advertises. Do you want to touch a little bit on that?
Can you clarify the question? So on scopes that the MCP
yeah, so like say the in OAuth you can define scopes, I guess, and then is there a way that we could map those scopes into capabilities? Just deviating a little bit from what we just discussed about, like more policy related stuff, but if one were to stick to the sort of the OAuth side of the world, is that a viable pattern? I believe you've written a little bit about that, or maybe I misunderstood. But,
sometimes it's a blur, the stuff that I've written, but
that's okay.
I have not written on that. I've made some comments on LinkedIn about like if you're going to, so a few different comments. One was around if you're going to expose MCP servers in the enterprise, what do enterprises think about also exposing? So you expose the endpoint and you can put it together, catalog and all this stuff, but should you also expose all the fine-grained roles and group memberships and entitlements and all the stuff that are required to call into these MCP servers? And the way that I framed that was, do enterprises care about exposing too much information about their network and access management security stuff? Some people said yes, some people said no. The interesting bit about that, though, later I realized, is you can expose that stuff but then you have to keep it up to date, because that can, the capabilities that are required to meet certain policies might change. And so if that goes stale, then not only some of the banks said, yeah, we don't like to expose, because like if we say, yeah, to call this API or to call this MCP server, you have to have admin role, you have to be part of the, or maybe not admin, but you have to be part of the HR's super restrictive group, and some of these other things. And if we're just publishing this open in the enterprise, then any attacker inside could say, "Oh, interesting! I didn't know that there's a HR super restrictive group. Let me go
grab that.
Find out what's going on with that." Yeah. Right. So so some people did care, some people didn't care. But so yeah, that's the thing. You got to watch out for that. Those things could change as well. But so as far as OAuth goes, like I said, inside the enterprise, scopes probably don't. I mean, you can use scopes, but using them as super coarse grain bearer token style. Hey, I have this token, so I can do this, right?
Yeah.
Versus, hey, I have this token, but something else is going to check. Can I really do this? So I think, the OAuth as the spec is written, like I said, doesn't really apply inside the enterprise, but you can continue to extend it and place more policy and stuff on top of that.
Gotcha. So that's on the policy side. Are you thinking more like OPA kind of thing? That kind of, in that type
that
of
style
policies?
doesn't have to be
Yeah.
OPA, but yeah.
Gotcha.
OPA. A new one that I'm just starting to dig into right now is OpenFGA. Cerbos, I think that's how you say that. It's another one. Caverno.
Yeah.
Cedar, AWS. So these style of policy systems, and what we've run into customers that have actually custom built and written their own before these tools were very widely available. So yeah, I mean, being able to plug in and enforce these policies is the main thing.
Awesome. So it's a nice sort of segue to the next section. To do some of these things, I mean, in the past, we've traditionally used API gateways. So in the agent world, can we use agent gateways? I mean, it's one of your pet topics, I guess.
Mm-hmm.
And why is existing API gateways are not suitable, and why do we need purpose-built agent gateways? And talk a little bit more about that stuff.
Yeah. I think API gateways can be used up to an extent, and I think that's what we see people doing. If you're calling out to AI models and you're trying to implement an AI gateway, I think there's a lot that you can do in the existing API gateways. I think when you say API gateways were built to fit that stateless API world, right? Where again, a message comes in, it doesn't depend on the previous message. Message comes into the API gateway. The API gateway will ideally, we want this to be as fast as possible in the API gateway, right? We sell an API gateway, Glue API gateway. It's built on Envoy proxy. We built it to be super fast. When we go to the market, we see one of the top qualifiers for how people choose an API gateway is performance.
Performance, yeah.
Right. And so the way the API gateway usually works is the request comes in, we look at the headers, we make some decisions about, all right, where this needs to go, what API in the backend does it really need to go to, and maybe we'll apply rate limiting and security policies and other stuff. And then, but we want to get this request out to the backend as quickly as possible. In the LLM or in the agent and MCP world, these protocols depend heavily on the body. If you're calling LLMs, you can still do a decent amount based on the headers. You probably will want to check what the model is, and then once you start doing things like guardrails where you need to understand the body, you're at this point where you need to understand the body. In the MCP world, hardly anything in that protocol is in the HTTP headers. Everything is in the JSON RPC messages in the body. Same thing with A to A and these style of protocols. So now we're going for a world where an API gateway built for stateless APIs, built to, as much as it can, optimize performance, to this world where it's totally different, right? And in MCP, things are stateful. A to A, things are stateful. So you have to understand what it means to be a session. You might in MCP, you can have the MCP server initiate a request to the client to say, "Hey, I need more information." You don't see this in APIs. So there's already a fundamental mismatch there. Now, can you hack an API gateway to get it? You can get anything to do anything, I guess. But so the reason why we built AgentGateway, which is an open source gateway primarily targeted at AI, is we want to maintain performance. We don't want to just throw performance out the window. There's this idea that, well, the LLM's slow, so everything else can be slow. That is a very bad way to look at it, because now you're going to build your infrastructure, and when you put infrastructure in place to support this stuff, you can't just rip it out, right? The LLMs are going to continue to improve. We're going to see, performance is not going to be a problem. And now you're going to be stuck with this real slow implementation that you hacked up because
you made that assumption, right? Yeah.
Stupid idea that, well, everything's slow, so everything should be slow. So we built AgentGateway in Rust to be as performant as possible. You can't get we've taken the fastest API gateway, and we're still at least 10 times faster than that with AgentGateway. And so, but on the other hand, now once you start to pay for the body inspection and that kind of stuff on AgentGateway compared to a regular API gateway, we're still faster, way faster.
Wow.
So performance is number one, but then number two, we have to support these protocols and do it in a protocol native way, not hacks. So for example, look at Envoy Proxy. We've been building on Envoy Proxy for the last 8 years. It is our core technology. Once we started doing this AI stuff, we realized Envoy was built for this one particular use, really good at this use case. For us to process the body and worry about all these other protocols, we basically have to call out of Envoy. Envoy has this mechanism called XProc, external processing. So for the AI stuff, we were calling out to XProc, and we were calling out to something that could process the body, do all this stuff. And the more and more we were doing, we realized we're building a second proxy. Envoy is calling out to another proxy. Once we got into MCP, it was very clear. Envoy is not going to support this natively. We have to call out to something else. And so it didn't make sense to build a Frankenstein proxy where this type of request, Envoy is going to do this type of request, will call out, and now it's much slower and all this stuff. And actually, the Envoy, what is it? The Envoy Gateway or AI, whatever the offshoot project is from Envoy that's doing AI stuff, is building it this way. They're building it as this almost sidecar thing that ends up being its own proxy.
Gotcha. Yeah.
And so we decided, instead of either try to rewrite Envoy or go down this really hacky, approach. We're just going to start. We'll build it from scratch. We'll build it the right way from scratch.
That's awesome. I'm going to be respectful of your time. We are at 11. Maybe now's a good time to tell folks about the Agent Gateway project and anything else that you want people to know about. What I'll do is, Kunal and I will post some of the links as well in the follow-up. We do in the YouTube video and stuff like that. Anything in particular you want to talk about, like the Agent Gateway as your closing thoughts?
Yeah.
Yeah.
Agent Gateway, we announced it back in March. It is built in Rust, used for communicating and securing and governing LLM calls, natively understands the MCP protocol, can apply authentication, authorization, observability, MCP, and A-to-A, agent to agent. We donated it to the Linux Foundation back in August. The project is taking off. Come kick the tires, give us your feedback, get involved in the code if you're interested, if you like Rust. That's a pretty exciting aspect of the open source that we're working on right now.
Awesome. Well, it's always been a pleasure talking to you. Really appreciate you taking the time to show up at a podcast and talk about this. I've learned quite a bit of things, and every time I talk to you, something new sort of comes up. Hopefully, it has been useful for everybody else as well. So, thank you very much, Christian.
It was my pleasure, Rajit. Always good to talk to you, and thanks for inviting me. Thanks for having me.
All right, awesome. All right, folks, we're gonna end up stream, and if there are any questions, we'll monitor it and respond. I will bug Christian if there's a couple of questions that I can handle. All right. So thank you very much. See you all.
Cheers. Thank you.
Yes. Bye.